We can start our session today. Um, okay. So, good afternoon, good evening, everyone, wherever you are. My name is Fide. I'm QA engineer, born and based in Tunisia. And with me today, Tobias, who is the speaker of this webinar. So, you are in the right place with Synapse QA and with the very interesting topic, AI in test automation. So before we begin, let me share my screen. Okay, already shared. Okay. Um, Whatever you are newly to Synapse QA activity or not, I'm going to show to you who we are, what we have done in the past, so that you get some idea. So so why we exist as community? Because we want to promote learning, sharing, and growing together as a team. Um, what is Synapse QA? Synapse QA is a community-driven space for everyone, especially testers. A few years ago, in 2020, Synapse QA is founded. We focus on helping testers build their portfolio. Also, we have actually hosted 4 global events that includes panel discussion, some hands-on workshop meetups, Taylor of Tales blogcasts, study notes, etc. And not to forget, we are also a community partner for 6 global testing conference, and of course we strive to empower the community with innovative ideas that could bring change, of course. So what else? What our values are, then you get a better idea of who Synapse QA is. So we want to contribute to better testing space by inspiring testers to open up their hearts and confidently share their knowledge with the wider community. We are on a journey of changing the testing community space and ultimately making the community better than before by empowering testers to accelerate their impact, boost their confidence, and overcome self-doubt. Also, our vision, a community-driven platform that connects talent to create an empire that expands beyond its page and transform contents more powerful by ensuring it's amply available. Our mission, so as I said before, learn, share, grow together as a community and redefine their creative ways of knowledge sharing. What else? So next slide. Um, So just to go fast, snapshot of what we have done in the past. There are events have done as Synapse QA community. March launched Synapse QA platform 2020. December 2020, Super Reads 2020. First of kind global write-a-thon. Also, in March 2021, Rise an anthology that celebrates women leaders to inspiring women with the history of the story of some inspiring women. Also, what's next? June 2021, two events in parallel. December 2021, Super Reads 2021 and Sparks. 2022, Super Voice and Public Speaking workshops, etc. Also, this is some our past height. So Rise, Taylor of Tailors, Supernova, Letters of Love, Super Voice, Spot the Difference, etc. Mhm. Here we come to our team. So Synapse QA is founded by Nitin in 2020, and the co-founder is Amala. Some core members Ram, Parcilia, Safina, and Kiki. Also, we have Enrique. Also, we have community ambassador Tuba, me, and Sojit. And always, we are looking for the community champ, of course. Okay, let's go next. Uh, So let's go to our speaker today, our session. It's AI and test automation by Tobias Muller. So brief description about Tobias Muller. With Project Tobias realized his dream more than 11 years ago to offer efficient IT consulting according to high standards and manage projects. His goal is to help shape modern development method and drive software quality. With his distinctive expertise, high quality standard and drive, he the testing market with the test automation platform, Test Result IO. He did not simply make existing things different, but together with his team brought a technologically new perspective to the subject. Also, as appreciated speaker, he ranked in the top 10 at the Automation Gold Conference with his talk about continuous validation. So let's welcome our speaker today, Tobias Muller. Welcome, Tobias Muller. Let me stop sharing so you can present yourself and start the topic of
Hello,
today.
everyone, and thanks for having me.
Hello.
Hi, Vida.
Hi, how are you today?
I'm living my dream. Actually, I caught the flu. So if I'm sneezing and snoozing around a bit, please forgive me for that. But I'm trying to get better.
Okay, no problem. So the stage is all yours.
Lovely. So let me enter the stage. Let me quickly try to share the presentation. And please forgive me if it doesn't work on the first try. All of that is rather new to me. But I think we should all see the presentation now. And yeah, once again, thanks for having me for Synapse QA. And I love to be here actually because I like this growing together part. So if you have any questions, just put them in the chat. If you think that something in my presentation is wrong, please correct me, put it in the chat as well. I'm actually looking to learn from all of you as well. And I try to give what I learned in the past from colleagues and customers to you today. And I guess we can get a better picture if we all do it together, if we all provide the information that we currently have. But let's start with the webinar. It's actually AI, and once again AI. And there's virtually no chance that you have not heard about AI at this point in time. It's revolutionizing driving, it's revolutionizing our lives, and yes, even testing. And as you've heard, I'm Tobias, and I'm the Managing Director at Project. And again, for full disclosure, we are the vendor of Test Results IO, and it's a test automation platform to close today's gaps in test automation. So in the beginning, there was a lot of chatter about AI because of Tesla's self-driving cars. People started to talk about machine learning, followed by deep learning, even so they didn't know the difference actually. And lately you hear a lot about Gen AI or generative AI. Again, everybody's talking about JetGPT and now GPT-4. Not so much about Tesla anymore, besides stock options these days. So there's one hype after another for artificial intelligence. And each of these buzzwords seems to land directly in software testing land, which makes sense as we, as testers, should be ahead of time, right? So today we don't do a general AI talk or product demo. And I'm not going to show you how to enter text in JetGPT's prompt. Today, we go through examples specific for testing, go through buzzwords, see what AI is and what it is not. Specifically in testing, it seems like everything is AI these days. And I show you a perspective on autonomous testing that is trivial, but in a way eye-opening, and I'm pretty sure you will see the two words autonomous testing in a different light afterwards. So before we do all this, let's set the stage and do a quick reality check, right before we dive into AI and test automation. So I assume most of you have a driving license. And how many hours of practical driving lessons are usually required to get such a license? I can only talk about Switzerland and Germany, but in here it's roughly between 16 and 20 hours. And then you do a test and you go on. The road is yours. You can drive everywhere in every country, being it driving on the left lane or driving on the right lane, depending on which country you are. And now think about Tesla's autopilot. By 2018, Tesla had more than 1.9 billion miles of training data. And in 2018 as well, Elon Musk promised full self-driving features by end of August. So it's 2023 now. And let's see what Tesla says about full self-driving capabilities. They say the hardware is capable for full self-driving, the software is not. In summary, 5 years are gone since 2018, and there are still no self-driving cars that go faster than 40 miles per hour in all weather conditions. Why is that actually important? I don't want to talk about Tesla, but it gives you a good relation. So after more than 1.9 billion miles and more than, let's say, 9 years of teaching the AI, there is still no self-driving car. A car that can do what you do after having lessons for 20 hours. And now compare that to software, for which you as a human require multiple days or weeks to comprehend how the system works. If you take the self-driving car problem as the baseline, you can imagine how far we are away from AI-driven autonomous testing. And just let me state it clearly, it is far. But that's not all. I'll show you towards the end of the talk what the FDA requires as the entry point for every software in the medical field, which actually might make you think. So we don't have full self-driving cars, something that you can learn within 20 hours. But apparently, advertising is already telling us that we do have autonomous testing, which is more or less like self-driving software. And to look at that, let's go one step back. Why are we even looking at AI? It is always the same. We are looking at the next best technology because either our problems are not solved with the current generation of technology, or the current one solved all problems but generated new ones. So if you think about automation in testing, or test automation, whatever you call it, what are the main challenges? Besides the myriad of smaller problems like keeping up with the updated frameworks, keeping track of test environments, and large problems like test data, I've identified 3 problems that I see repeating in my daily business. Number 1 is flaky tests. The test passes sometimes and sometimes not, without any change to the subject under test. And we know that the subject under test reacts the same from a functional point, but might differ from a performance point. And the typical example here are the wait or sleep statements that nobody of us use, but this, the wait was a bit too short, network latency is higher than usual. I think we've all seen that. Or the page generator creates new code for your web page. So the web page still looks the same, but the div structure is completely different after the last update. And our tests fail, even so the subject under test actually works. The next challenge I see is technology dependency. So for every platform, there's different framework. And on every platform, there's software that doesn't adhere to the standards of the platform, and it needs workarounds to make it testable. And all of this special code needs to be maintained. Otherwise, we end up in broken automations again. So the real problem is not the dependency itself. The real problem is that we have to do more and more maintenance. And more frameworks to maintain, more tests to adapt to changes in the underlying framework, etc. And this brings me to my last major problem, the expert availability. The amount of software, of digital products is increasing. There are just not enough testers in the future, or there might already not be enough today. And replacing testers with automation didn't help much in terms of expert availability, as most automation these days is not stable enough. So I've seen it multiple times. Once the people in charge left the company, the automation got more and more useless. And the quality got worse as the development still continued naturally. And then the automation didn't work at all, or it was restarted from scratch by some new hire. And now comes AI, followed by the advertisements that claim that AI can solve all of these problems, and we end up with fully autonomous testing. And we make it simple. We don't talk about the level of autonomous testing. That's already marketing speech per definition. So if there is autonomous testing, it must autonomously test. Not halfway with human interception, and we call this level 2 autonomy. So no, it's level 5, full autonomous testing. And let's take a look at testing to understand how AI could actually help. So we look at the 3 stages of testing, and yes, I made that 3. Sometimes you'll see 4, sometimes 5. I like to have small sets, so it is 3. We all start with the design. So, and that, for me, that includes everything we usually do to have a plan. We define our goals, we define our strategy, we explore the software, we write test cases or test ideas. In other words, we prepare everything for successful execution. And from an AI view, we do a lot of creative work in this step. The next is execution. So I'm coming from an extremely regulated environment, and execution meant execution of test cases, which is interesting the first time, the second time, and perhaps also the third time. But at some point in time, it is not fulfilling anymore. Not much creative work, but more precise work in this stage. And our first customers' test cases were required, and they had to be written in a way that someone freshly hired from the street could actually execute them without any prior knowledge of the software. So there are more creative ways in execution, specifically if you do exploratory testing. But as this talk is about test automation, I assume the execution part is the one that everybody is trying to automate first. And after we designed our testing and executed it, we want to get learnings. So we investigate our test results, add perhaps a few more tests to get more clarity on specific behaviors that we've seen during our initial testing, and we are ready to generate value by showing potential risks. And that is what testing does in the end. It's like we are identifying risks and giving insights only a customer could give otherwise. So without testing it, the next logical point in the chain would be the customer who is exercising the product and would have roughly the same findings, hopefully, that we already had. And I think you waited for it, and here it comes, AI, which was already a hype in the 1960s, and another hype in the 1980s, when expert systems and Lisp were actually hyped. And I still remember when I was in the university, we also developed expert systems in Prolog and stuff like that. I'm pretty sure a lot of you can still remember stuff like that as well. And the current hype for AI started around 20 years ago. And I think the most intriguing part of AI, at least that is what I get in all of my discussions, is the perception that artificial intelligence rebuilds human intelligence. So we all need to understand that it is still only algorithms. I'm pretty sure now everybody yells at me that human brains also work with patterns, models, and programs, and I get all of that. And that is, as far as I know, the currently accepted state of science. But most of those, we don't really understand. That's the problem. We assume they are there, but we don't understand how they are built up, and we don't understand how that actually works in the brain as a like a complete device, if you can call it like that. We don't even understand the brain development of a baby. From observation, we know that there are phases of growth in which more complex patterns are established, but that is just the observation of the result. So it's not that we understand how it works, we just understand that it works and what the result is. And I mentioned that because I want to map artificial intelligence against another class of algorithms, genetic algorithms, and I'm pretty sure a lot of you have heard about that already. But the interesting part is if you hear genetic algorithm, no one would ever compare that to how human reproduces, to say it politically correct. But that is more or less how genetic algorithms work. So we copy nature. We have a fitness function which allows us to evaluate how good the result is. And we always use the two best results to generate an even better one, in simple terms. And because mankind survived, because of adoption, we implemented some randomness to be blocked in local optimums. So we want to be sure that we are not in some kind of local optimum, but we want to make sure that we find the global optimum. So perfect. What we just did is like we compare the results of something and take the two best ones and generate a new system out of that and give in some randomness. That is more or less Darwin's theory of survival of the strongest. And again, that is what genetic algorithms do, but nobody would actually bring that in connection to human. But for AI, it's completely different. Everybody that uses ChatGPT, for example, thinks that the answers are better than the answers from humans, somehow completely neglecting that it's just statistics. And yes, my PC, even my phone, is far better in calculation than I am. Do I think it's superior? Yes, in that area it is. Mass is defined, life is not. So AI is still mass, it's not about being a human. So I love the solutions that AI brings, and I love the mass behind it. What I think is a bit strange is the perception. And it's interesting to read this actually. Machines will be capable within 20 years of doing any work a man can do. And if you follow the discussions right now, I guess you wouldn't say like it's within 20 years, but it's more or less within the next 5 years, all of us will be without a job and we will be replaced by ChatGPT, GPT-4, GPT-5, GPT-6, or a new system or new based on LLM or whatever is the next best. Like LLM is based on transformers. Meanwhile, we do have visual transformers as a deep learning technique. Whatever comes next will replace us for sure. It might even erase us from the earth. But the interesting part is the statement I'm currently on the slide is from Herbert Simon from 1695. So he said, like in 1685, actually the machine should have been capable of doing all of the work that a man can do. And it's still not. It's still not the case in 20, and it's still not the case in 2023. We don't even have self-driving cars yet. Just keep that in mind. So AI is an interesting kind of algorithm. And that being said, before we look at AI or non-AI techniques that are sold as AI or even better as autonomous testing, let me ask you this. Did you ever ask a vendor that talks about how AI improves test automation, how they actually test their AI? And did you notice that there is no testing tool out there that claim to be able to test AI engines? Sure, some claim they can test a chatbot, but not the underlying AI engine. And I was bold enough to ask vendors actually, because I was interested in like, how do you test your AI? And the answer I got was silence, which makes sense. Because the thing is, how do you actually test AI? And I attended a talk from someone from a Swiss, from a big communication companies in here, where the discussion was like, how do we test AI today? And naturally, there are metrics like accuracy. And those are used in the model definition, actually, how to test the model. But they do A/B testing. So they actually test the old version against the new version of their model with humans in the field. And whatever is better, actually. And based on that, they build the next version. So it might be that the new version is worse or perceived to be worse than the previous version. And they then they just scrap the work on that and go back to the original version and build on top of that. So let me ask you this. If nobody tests their AI, and again, it's just algorithms in the end, how can we trust the AI and testing tools to be able to test? So by definition, and that's an important fact, AI has a percentage of accuracy, which is always less than 100%. So you have false positives built into your testing system if your testing system uses AI. And I've seen an example from a vendor, and that is actually interesting because it somehow summarizes the state of AI right now in testing and test automation, where they test an image classification AI. So they have a huge video on their webpage how they can test image classification AI engines. And that's interesting. If you go through the video, actually what they do is they take 7 images of gears, and they expect that the AI under test identifies all of them as gears. And that is, to be honest, not how you should test an AI system in an end-to-end way, because that's exactly how the model is already tested in the beginning. We always have a training and a distinct test set. And the thing is, as long as I see examples like that, I see AI in test automation as a buzzword. And it's interesting. I'm pretty sure you followed all of the discussions in AI, in test automation, and all of the marketing, and you see a lot of AI supported. Or now, meanwhile, that's coming from Gartner. It's like it's not artificial intelligence anymore. Now it's augmented intelligence. So intelligence that supports the human in decision making. But let's get into our AI and test automation examples. So I actually took real life examples, and I stole some screenshots from vendors and tried to make sure that I remove or at least blur the vendor and product names as best as I can. But I want to show you different problems or challenges based on these examples. So it's not about blaming those vendors, not at all. I guess everybody is doing the same game right now and talking about AI in full scale without having AI implemented. So let's look at the first one. And the thing I received that with an email which said, our AI quickly yielded over 800 unique tests, more than 5 times the number of manual tests that were being executed. So what does that actually mean? And that is a screenshot from their presentation, from their video. It's like an hour long. And the idea is that they do have autonomous testing. So like you give the software the URL to a web page or a web application, like a single page application, and it is going through the system and identifying all of the required test cases. And then you get the statistic which says like, hey, I do have a high value risk here on the top, and I have human written tests. And I covered 20%, roughly 20% of my whole system. Then there are AI-generated regression tests, whatever that means. And what's the difference between AI-generated autonomous tests? But nevertheless, so we do have AI-generated regression tests, and we get up to 50%. And with AI-generated autonomous tests, I assume we reach close to 100 if you look at the distance. It might be 90%, whatever. The interesting part is actually how it maps against the high-value risk. So we do have this 20% human-written tests, which cover the high risk and have a high value. And now we automatically add 1,000 test cases that do not have a high value and do not cover a high risk, but which can potentially fail. So what happens now? If I have 1,000 test cases and 125 test cases fail out of those 1,000 test cases, none of them were written by humans. They are all of those generated autonomous tests. What does that mean? I can't give you the answer. It's just like we are adding a lot of noise to something that we cannot handle afterwards. And that is the same, like I've seen it like let's say like 15 years ago, model-driven test automation. And I was at a conference where the guy was presenting like the newest software for model-driven testing, where you define like all of the transitions. So you have different pages and you can define all of the transitions. And that thing generates test cases. And his biggest problem was actually that the model generated 10,000 of test cases. Because the problem is that is not maintainable. You cannot have any useful answer if of those 10,000 of test cases, 1,250 test cases fail. You need a human to understand that. And that is a problem because we cannot cope with that big amount of numbers. But let's actually look at what the software is doing. That's even more interesting. And I do have a fancy animation in here because it's autonomous testing and it's fancy. So what it actually does, what it actually gives you is this. And I also took that as a screenshot from the video. And that is more or less like a sitemap. Because what you need to understand is like, And testing a software is not clicking through links, and that is more or less like what this autonomous. So that's the current state of autonomous testing. It's more or less like I can click through your software. So that's far more than the monkey testing that we had beforehand, that we just tested randomly for crashes. Meanwhile, we click on useful places. But there are multiple problems with that approach. This all reminds me on property-based testing. So property-based testing is a technique that's coming from unit testing, where you actually define the properties of an algorithm and then have a system that is generating those unit tests based on the properties. And with that, you have the perfect test set with 100% of coverage. And all of that is brilliant in theory. The only problem is, like, if you are able to define the perfect properties, you are actually able to implement that based on the perfect properties. It's like none of us have ever seen the perfect requirements, right? That is where the first problem actually starts. Like, there's a set of requirements, and the problem is it's not done, and it's far from perfect. And property-based testing actually assumes that you can define all of the required properties of an algorithm upfront. And it looks like, and then it can generate all of the required tests. That is true. We actually had an expert on that in a call for our network dinner, and he showed how that actually works. But the problem is, we are not able to provide the input to that. And that's the same for this autonomous testing that I'm showing you here right now. It is actually exercising the software. So it's not knowing what the software should do, but it is actually going through the software. It's a bit of an approval process, like you know it from Aptitude IS. Basically, like I take a baseline, and if there are any changes in the screenshots, I need to approve that. The problem is, like, that's a completely different approach than functional testing. And somehow that is a mismatch. So what you see as autonomous testing right now is more or less generating a sitemap and trying to go through all of the links. And you can also see it on the amount of dots, because the problem is, like, put in one drop down actually on a web page with 10 options, and the amount of dots should be exploded by the thousands, because you have all of those dots in here. So if the first dot would actually be a selection of 10 different elements in the drop down, that would all of the dots would actually multiply by 10. And that just doesn't work right now. So that is more or less like the current state of AI and testing, or autonomous testing in the design phase. Because that's a difficult task. It is actually difficult to identify how to test the software. I need to understand the software. I need to talk to all of the different stakeholders to understand what the software should do. And so if you would have AI in here that could actually simplify the task, that would be brilliant. But right now, I cannot see that it is on the market, even if people tell you that. Keep that in mind. The next interesting part is self-healing. You all know it from the test execution. I'm pretty sure you used Selenium, Playwright, Cypress, whatever you're using. They are all using these ID, CSS, XPath-based selectors, and sometimes they break. So that is one of the reasons of flaky test cases. Some structure changes, the selector wasn't good from the beginning on. And I think it was like a few years ago, 5 years ago, where the first posting came up about self-healing selectors. We can make your selectors survive any change in the application. Yeah, and I guess you can already imagine by the wording that doesn't work. So, but let's look at one of the examples that I found on the web. And I had a little discussion with the vendor on that one as well. If you look at that, it's a self-healing library for Selenium test automation. And I guess you all know it, sooner or later there will be the no such element exception due to changed layouts or broken selectors. I guess we all know that. So it says it's an AI-powered open source library that improves the stability of Selenium-based tests. Lovely. The interesting question is now, and the source code is readily available on GitHub. So what I did is actually I went to GitHub and went through the source code. And then I asked myself, like, okay, where is the artificial intelligence in here? Where are whatever kind of deep learning, machine learning, whatever you have, whatever you use, whatever kind of GAN networks you use, whatever you have, where is it? And I didn't find in this code. So I asked the authors and said, like, hey, where is your AI hidden? I'm really interested in seeing how it works. And they told me something about the longest common subsequence algorithm. I highlighted it here because I found it afterwards in an introduction as well. So it says what's inside. It specifically says under the hood, machine learning algorithms are used that analyze the current web page for changes and modifications of the longest common subsequence, based on the longest common subsequence with weights. Yeah, that's interesting. So you see that this small excerpt that I have here says like it's an AI-powered system, it uses machine learning and yada, and all of that. In the end, it uses LCS, and LCS has nothing to do with artificial intelligence. It's from the dynamic programming context. So it's a completely different set of algorithms. As you remember, we already spoke about artificial intelligence algorithms, we spoke about genetic algorithms, and dynamic programming is again a different kind of algorithm system. And I talked to those guys actually and asked them like, hey, okay, the LCS, I went through the whole internet because I remembered from university that is not artificial intelligence. And I just want to confirm that's the case. So where is actually your machine learning? And the answer was that, yeah, we store the state of the current web page and compare that to the new version. So the system learns actually something. And that's, again, and forgive my French, that is something that you shouldn't say because it's not artificial intelligence. That is how LCS works. So you have a sequence and you have a new sequence and you actually compare subsequences in the sequence tree. And you do that in a clever way and stuff like that, but nevertheless, it's not artificial intelligence. And that is interesting to know. So a lot of stuff that you hear in test automation, like AI in test automation, if you look at it underneath, it has nothing to do with AI. Even if you say that AI is only algorithms and it's nothing fancy, the funny part is, even that is not met in test automation right now because it's not even AI algorithms. And we all expect like ChatGPT stuff. And not in test automation right now, apparently. Let's go to the next example. So we looked at the design phase of testing and seen one example which claims like, we have AI to solve the problems in designing test cases. Then we looked at one for the execution. So say like, okay, in the execution, one of the biggest problems as we identified is flakiness. So we use auto-healing to solve the flakiness problem, which is AI-driven auto-healing. And we actually busted that as a myth. And at least in this one instance, identified that it has nothing to do with artificial intelligence. But now comes an interesting point. The analyze part. So actually, that is also something where human intellect is still required. So you have all of those results and assume all of your automated checks worked as expected and they give the right results, some passed, some failed. And you can actually automatically investigate the failed ones and give the management the overview of what the risk is without doing any investigation at all, without even looking at the test cases anymore. You just press the button, or not even that. After the run is done, you get a detailed information on where the risks are. And what even better, what the likelihood of bugs in different areas are. And I found a system, which is also open source, which uses TF-IDF. And TF-IDF is actually a vector that is used in artificial intelligence. So that is actually in the class of artificial intelligence algorithms. So it's called the term frequency inverse document frequency vector. What does that actually do? And it's an interesting piece. What it does is it tries to identify how important a word is in a collection of documents. And think about that. So how did that vendor actually implement it? What they did is like, if the software crashed or if it created an error, they took the stack trace and then generated a TF-IDF vector of all of the words in that stack trace. And now think about how clever that is. Whenever there is an error now, they do the same for the stack trace they capture for the new error and actually identify the closest stack trace in the past to that stack trace that is now the case. And that is actually what I would call AI. and what actually the university will also call AI. So if you study it, you would say like, okay, that is artificial intelligence. And I would even go so far and say like, that's even deep learning, because it continues to learn while it's executing. In the beginning, you are training the model. So you tell them like, yeah, this stack trace is actually in the following area, and it generates the following problems. And you do that multiple times, multiple iterations. And at some point in time, the system is able to give you that information automatically based on the stack trace that it captured. Amazing, amazing technique. The only problem is like, it doesn't fit development. If you think about it, a single refactor in your software and all of your stack traces are different. And to be completely transparent, they do some cleanup in those stack traces. So they remove some dynamic information, some unrequired information to make sure that the stack traces they capture are as sharp as possible. But again, the problem is refactoring code is a common practice and is actually a good practice in software development. And refactoring code can mean that all of the stack traces are different from iteration to iteration because you refactored code into different methods, different components. And specifically in microservice architectures, you move code around to different services. You even create new services as soon as you see that the component is growing too big and stuff like that. So while that is an amazing approach, if you think about it, it doesn't hold true in reality. And that's the problem. So that is AI applied, but I think in a not so good way. And it's also from the same vendor, actually. It's interesting. It says like machine learning and finding, and now it comes prediction of fails. So it can even predict where something will go wrong. And I didn't find any information on that, actually, neither in the source code nor in the documentation, how the prediction would work. But I assume that it's based also on statistics again. It's like, if there is a change in the following component, then the likelihood of having a bug is dependent based on the likelihood in the past, and we can predict the likelihood of a new bug in that area based on the changes. And that, by the way, works. That is something that can work, but it actually needs to have a stable product again. If you do a lot of refactoring and generating new services, new components all the time, and stuff like that, is proven to not work. And now I'm getting to the end of my talk, more or less. But I do have some interesting thoughts. If you think about AI and test automation, and if somebody is selling you autonomous testing, and again, I love artificial intelligence, and I see the possibilities that are coming with artificial intelligence. And we are also playing around with visual transformers. I mean, that shouldn't be a secret. Transformers are the hot thing right now in artificial intelligence. And we're looking at visual transformers in comparison to convolutional neural networks, and it looks promising. But you see a lot of hype and a lot of buzz on autonomous testing right now. And I learned that actually from the FDA, so from the US Food and Drug Administration. There's something that they call the intent of use. So before you release a medical product or software in the medical field, you need to define the intent of use. Who is your user? How will they use the software? What is the benefit of your software? Why should any user be interested in your software? And that's an interesting point. If you think about autonomous testing of a software, the artificial intelligence needs to be able to understand the intent of use. Otherwise, you generate sitemaps, you follow graphs. You can do it as fancy as you want, but as long as you don't grasp what is the idea of the software, you will never know if a behavior is a bug or not. Or alternatively, you have an artificial intelligence that is showing you all of the findings, and you as a human need to classify it as a bug or as being it as okay. So that is, again, the approval workflow, but that doesn't scale, because if you have thousands of bugs simultaneously, it takes weeks to classify those bugs. You need to investigate them. But if you do have an artificial intelligence that understands the intent of use, we actually find autonomous testing. That's true. because then the software understands what is the idea behind the software and what would be acceptable to the user and what wouldn't. And think about that. It's extremely simple. As soon as we do have a piece of software that understands another piece of software, what the intent of that software is, it is able to do autonomous testing. That's actually not so tricky. But you know what? As soon as we do have real autonomous testing, and that's the interesting part of it, we don't need testing at all. And I know that's a provocative statement, but the thing is, again, if I do have a piece of software that understands the intent of use, why can I not just act to be that software? Because it understands what I'm expecting from it. So it can just act as the perfect implementation of that software. So it doesn't need to have any testing anymore. So if you find a GAI, so general AI, that can actually solve that problem, then we do have autonomous testing. And as soon as we have autonomous testing, we don't need testing anymore because the software just acts as we expect it to act. That's interesting, isn't it? So whenever you read something about autonomous testing, ask the vendor, so wait, if you have autonomous testing, why do we even need testing at all? So if you can do it autonomously, why doesn't your software just behave as a software that it wants to test? It's pretty intriguing, and I'm pretty sure no of the vendors will have any answers to that. So what do I see as the future for artificial intelligence? What I see is like we are getting away from all of those different selectors and get on a track like where Amplitude is close to already, or other tools as well, is like we are going into the direction of visual cues. So having visual selectors and then use object identification, because that is actually where transformers are also extremely good, as well as CNNs are also extremely good in that. And then we can actually train the software to identify buttons, drop downs, and stuff like that automatically based on a small set from the sample. And we can actually train it on the behavior, what should be meant. And it's pretty simple on the button. If you click on the button, you can tell the system it should go to the next screen. But it's more difficult if you have a drop down of elements and what should happen if you select any of those elements. I mean, as a tester, I'm pretty sure you have seen everything like if you select an element, nothing should happen because it should only happen after you click on the button, or you select an element and the whole screen is changing, or you select an element and the pop-up is coming up, or you select an element, it tells you, oh, there's a validation error, you cannot select the element while you didn't enter your email address, and stuff like that. But we can teach the system to that, because that is component based. So we can give it small components and we can teach on those components actually what the expectation is. And that then brings us to semi-autonomous testing, where we can actually put components together. That's the first part to autonomous testing. If you want to call it like that, I would still call it automation in testing or test automation, because in the end, it's still you putting those flows together. And that is where I see the future. And I think it is time to finish this webinar and actually look at the questions.
Okay, thanks a lot, Tobias, for this presentation. So let's start by the question. The first one is how AI can improve efficiency and make tester more productive without replacing them.
Yeah, I think that's a good point. The thing is, it will not replace testers. It just will not. And all of the vendors are going to that direction and say like AI stands not for artificial intelligence but augmented intelligence. And and how can you improve the efficiency? Is exactly what I said, like those TF-IDF vectors and stuff like that. So there are small tools. If they are implemented correctly, you can actually improve your performance tremendously. It's what I said. Like if you're working on a dedicated set of software and you can use those stack. So if you have a maturity in your software and you don't do a lot of refactoring, you could actually apply that technique today to not be required to analyze failed tests by yourself, but you could actually just tell it, okay, that stack trace looks like the stack trace like a year ago, and that was in the following area, and it was created by the following code change, and it seems like the same happened again today. So that saves a lot of time.
Okay, thanks a lot. One more. how you as a tester see the rise of AI and its impact and benefits to testing and automation.
The rise of the AI sounds like a Terminator, isn't it? So I see the rise of the AI actually as something where you think like, as I've said in the talk, it's like there was a hype in the 1960s, 1970s. There was a hype in the 80s. There is now a hype since like 15 years, and what are its impacts and benefits? The benefits is like you do have a new set of algorithms that, if applied correctly, can save you some time. It's like a computer per se. So we use computers to save time, and I think that is one of the biggest benefits that we have. Um, Impacts to testing and automation, as I think heard in my talk, I don't see many impacts to the automation, so it doesn't make it more stable today. I know that everybody is claiming that, but if again, talk to those vendors and ask them how they test their system, and you will actually see that they cannot give you an answer. And as long as they cannot give you an answer, how would that make automation actually more stable? So for testing itself, I mean, looking at all of those videos that you see about ChatGPT, that gives you actually ideas on how you could test software. Yeah, that's a brilliant new source on how you can test software. I mean, that is what we are looking for, isn't it? Like, we are looking for sources that give us input on how to test software and how users will actually use software. So, like, we're talking to product managers, stakeholders, customers. We're talking to everybody, developers. We're talking to everyone to get input on how we should test the software, how we can test the software, what they actually expect from the software. And I guess LLM-based systems, so like ChatGPT or GPT-4 systems, are a new source of potential information.
Okay, thank you. We have one more question. What is it? Okay. So, do you see that low code and no code automation tools that started to use AI can replace full code automation?
Yeah,
Good question.
it's a typical question. The thing is, like, again, I was looking at one of those low code tools using AI, and I think the AI part is not the important part on low code and no code tools. My general stance on that is that no, low code and no code tools cannot replace full code automation. Because in the end, what you need to understand is, like, any no code tool is generating code in the background. And if you and people seem to be, no code is another holy grail right now. They seem to forget, like, moving boxes around and making errors between those boxes is also programming. So that is also, if you do have, if you need to understand loops, if you need to understand expressions, if you need to understand conditions, and that is something that you also need to understand in no code environments, because you need to do verification steps. You are doing coding. It's just another marketing thing in comparison to, like, yeah, coding environments are how would you say, are frightening people, and now we put fancy boxes around it. But the stuff that you're doing in the background, so the logical thinking in a way, like, what is the next step, how do I interact, how do I verify, that's the logical part, and you still need to understand how that works even in no code environments.
Okay. One more. Can you share a path for start learning AI mixing with automation?
Yeah. Use any of those open source tools. I mean, just start using, like one of the examples that I know is, like, how's it called, Selenium. That is again, it's not using artificial intelligence, but you will see how intelligent algorithms will actually solve problems in automations. I think that's the only path forward, is, like, start using it, to be honest. That is how we learn. And for mixing the stuff, and again, it's not mixing. I see where you're coming from, but I think, like, it's like the artificial intelligence algorithms. It's just enhancing the current experience, and it's not like I have the goal of having artificial intelligence based testing, and I have automation, and I start mixing AI into that, and I need to have kind of transition to the goal of having AI based testing. It's just another set of algorithms.
Okay, thank you. Uh, I think we are done with question for today. Thank you a lot, Tobias. Just
Thank
before
you.
we end our session, I will reshare my screen. Okay. Mhm. So, we are looking for community champs. We are inviting passionate testers in the community to join our team. If you enjoy the experience of giving back to the community and helping others grow, this opportunity is for you, of course. As my experience, this is something to challenge you to be a better version of yourself. What else? We are done. Thank you a lot. Thank you, Tobias. Thank you, everyone. Um,
Thank you,
Thank
Vida,
you.
for hosting me, and thanks, Synops QA, for actually having me on that chat.
Thank you. Thank you a lot. Thank you for deciding to spending your time with us today, all of you. Thank you. Bye bye.
Thanks. Bye.
Bye.